Hello guys, welcome to my channel. This is Java Data Structures and Algorithm course. Today's topic is implementation of generic single linked list. And if you have not already subscribed to my channel, please subscribe and promote the content. Thank you. What is generic programming? Java included support for writing generic classes in Java to SE 5.0 or JDK 1.5 version. The generics framework allows us to define a class in terms of a set of parameters that can be used as a type of declared variables, parameters, and return types within the class. Before Java SE5, generic programming was heavily dependent upon the Java object class, that is the root of hierarchy in Java programming language. Example, public class, my class, and this is how we enter parameter in the class. This is a generic class that can be instantiated with any class type such as integer, string, and double. Features of the linked list. This is a simple data structure. It uses dynamic memory allocation. It allows us to use the memory only needed to store the number of elements we want to store within the list. It requires ON memory. It is a linear container. It uses linear traversal to access any arbitrary element, either to search or to delete. It is efficient in addition and removal, where the best case happens at the head node and the worst and the average cases will be ON. There is only forward traversal. We can also implement backward traversal, but that will be very costly because of the singly linked list. Thank you guys. Let's begin our coding. Hello guys. I have created Java project in NetBeans and added 3 classes. This class is going to be used for the testing of the linked list class. Node class, this will be the generic class, and this T parameter can be used to invoke the objects of node class with different data types like integer, float, string, or any custom class. And this class will be used to make to build the linked list. And this is the list class. This also have the parameter, and this parameter will be used for the declaration of variables or data, return type of the methods, and the parameters passed to the method. And this class will be invoked by using this parameter. For example, we can use to invoke this class for integers, strings, and similar other Java classes. Let's begin our coding. Let's start with the node class. So we need data type, data to store, private T data. And understand this. This T is an arbitrary data and template data. You can say if you are C++ programming. C++ used to call this template programming. Java used to call it generic programming. And this T will be replaced with the parameter passed at the time of invocation of this class. And reference to the next, private node next. Okay, now the constructor to set up the object. Public node, the empty node, data is equal to null, and next is equal to null. Public node, and this will be pass the T parameter. This data is equal to data, and this next is equal to new node, or let's say null. At the time of invocation, it is also null. Okay, instantiate object of node class, data to store within this node object. Now simply we need getter and setter functions. We can generate them, insert code and select both the variables, instance fields, and generate. We will have these standard getters and setter methods. These are sufficient to be used in our class. So that's it, guys. This is our complete node class. Let's create list class. This is a list class. Head of the node, head of the list class, private node t and head, and count variable, private int count. Okay, now class constructor, public list, and this will create an empty list. So this dot head is equal to null and this dot count is equal to 0. Now function public void add front and data t data, function to insert a new node with data to the front of the linked list. This is data to store. Okay, now here we first create new node t, and node is equal to new node and pass the data. Okay, now if it is empty, let's write one function, public boolean is empty, return head is equal to null. Check that list is empty, return indicate if the list is empty. So we call this function here if this dot is empty. It means head is null. If empty, store at head. So simply store new node at the head and increase the count. Let's say we can use increase here, count plus plus. Now if the list is not empty, so what we will do, we will do set the new node next reference to point to the head. Node dot set next is equal to head and store the new node to the head to make it first node. Make it first node, and this one set the head to the next pointer of new node. Okay, that's it. Over add front function is done. Now add to the back, or simply add, you can name any way, public void add back, same t data, function to add the new node with data at the end of the list, data to store. Okay, same way, first we check if empty. If this dot is empty, so we simply pass this on to the front function. This dot add front and data. That's it. Otherwise, else, it means list is not empty. So we have to add to the end of the list. So what we will do, we will navigate to the last node. So node current is equal to head, and we move, navigate to last node while current dot get next is not equal to null. So we move to the next node, get next, and here we set the new node to the next reference of last node. So what we will do, current dot set next and pass node. We have not created yet. Let's create the node. Create new node, and this is node is equal to new and data. Okay, that's it. This is our add back function or add function, whatever you want to name it. Now these two are the main functions. Now the removal function, public, let's say void, or let's say boolean remove. So t data, as usual, this data we will going to remove an element from the linked list. Data to remove first occurrence, because it is possible there are more than one copies of this data or duplicates exist within the list. So return true indicate operation is successful or failed. So here check if list is empty. If this star is empty, so we return false because there is nothing to remove. This is case 1. Case 2, data exists at the front of the list. So what we will do, check if head dot get data dot equals. Why we are using equal here and not the let me explain it later. And data, okay, here using equals and using this will compare actual objects with data inside it, and this equal to operator, this will only compare references, not the actual object. So this is good for intrinsic types, int, float, double, it, char, etc. And equals needed to be used for objects like float, integer, string, or any custom class. So this is the difference between these two. So if the data exists on the head node, we will remove head node by storing the next node to the head. Get next. That's it. And let's say we reduce count minus minus and return true. Okay, we need to increase count plus plus. Okay, now else node may exist between other nodes or last node. So we navigate to find the node to remove. So node current is equal to head, previous node is equal to null, while current is not equal to null, and current dot get data dot equals data. So we will navigate till we reach the last node, and we find the node that has the same data, and we keep on navigating. We can even remove this condition. We don't need this here, and we just navigate till the end of the linked list, and we check condition here, check node data here. If current dot get data dot equals data, and here we remove it. So pre dot set next current dot get next. So this will skip the current node. So when it is out of so we will set the next pointer of the pre to the next pointer of the current node and skip the current node to remove it. And Java uses automatic garbage collection, so this will be removed. This is in contrast to the C++ programming. In C++, we have to delete the current node, but it is not required in Java because it automatically garbage collected. So we reduce count and break, or let's say we return from here, return true. Okay, now here we set the pointers, update navigation pointers. So we set pre to the current node and current to the next node, get next, and here we return false because node not found with data. Okay, that's it. This is our delete function. First case is empty, return. Second case, if it exists at the head of the node, remove the head node, reduce count and return. Next we navigate to find the node with the data and remove it by skipping the current node, and reduce the count and return, and update navigation controls so that we can move to the end of the linked list, and also keep track of the previous node so that we can skip the current node. And reach here means the node does not exist with the data, so we return false. Next, public int get size, or let's say size. So we simply return count here, count the number of elements in list, number of nodes. Okay, now we will write a print function, public void print display the list to screen. Okay, so we s out, let's say this one, s out, let's say closing, and if not, this dot is empty, we display. I wrote this short template, so easy to put frequently written codes. So we will print let's say minus 10D and head dot get data, first node. Okay, now the rest of the nodes. Node T current is equal to head dot get next. Why get next? Because we already printed the head node here. So this will, I am doing this to display the list in a Java style, as we used to print the array list or other data structure within square brackets. While current is not equal to null, so we print current node, and we can copy here, copy this one, and we put a comma and space, and this will change to current. And navigation, current is equal to current dot get next, and that's it. We need to change this to print. Okay, print something like 1 2 3 4 5, this style. Okay, that's it, guys. Now let's test these functions with 2-3 different data types. Okay, test with integers. So create the list integer. This is how we pass the parameter to the generic class. Integer list, new list. Okay, now let's print state of list. So as out, let's say size of list. Int list dot size. Next we write print f dot printf is list empty %s, and int list dot is empty. Okay, that's it. First, now insert data. So s out, insert 4 to the list, int list dot add front, let's say front, and change it to insert to front. Let's say we inserted this one, copy the size, and s out, list is now, and int list dot print s out, new line. Okay, this is inserted at the front. Now again insert to the front, let's say 7, and now back, insert to back. So this should be let's say 8, another back, let's say 10, now change the function back. Okay, let's test this one. So running it, we get the result, and we see how we are doing. So first we have empty list, size 0, then we inserted 4 to the front, so size becomes 1 and list becomes 4. Insert 7 to the front, and 7 comes to the front of the list, 2 inserted. Then we have 8 at the back, yes, 8 at the back, and then we inserted 10 at the back, and 10 at the back. So over add front and add back functions are working fine. Now remove, test remove, while not is int list dot is empty. So int x is equal to let's add a front function, list public int get front, return head dot get data, not int, we need to return t. Okay, get the first element, return first element. Okay, so instead of integer x is equal to int list dot get front. Now we print it as out front element is equal to sf x dot int value. Now remove it, int list dot remove x. Now print the state, size and list. Just copy paste this code. So this will run until the list becomes empty. Let's check it. So let's run it. I added a condition to the print statement. If the list is empty, it will print the empty list message and return. So let's run it. Okay, so we already checked these. So the next front element 7, it is removed. Front element is 4, it is removed. And front element is now 8, it is removed. And front element is 10, it is removed, and we are left with the empty list. So it is working with the integer data structure. Now let's just add list string. Okay, now str list dot add front, let's say John. Str list dot add back, let's say Mary. Str list dot add, let's say front Peter. Str list dot add, let's say we added it back Smith, and we print str list dot print. Okay, now remove, we are just checking for a string data type, while not str list dot is empty. So sf element is %s and n. So str list dot get front, and then we remove dot remove front element. Let's store it to some other string. Let's say x str string str and remove it. That's it. Let's try this one. Run. Something wrong here. Formatter wrong. So it was due to the formatting of this one, because I put a D for the integer. We supposed to use string representation, because all the classes normally implement string, two string function. So let's run it. So this is over. Testing for the testing with the string data and removed. Thank you. That's all for the implementation of generic singly linked list. And if you have not already subscribed to my channel, please subscribe and promote the content. I have also developed a website, codinghelpline.org. Please use to visit there to find the source code, and also subscribe to my channel and promote the content and help me promote my channel. Thank you guys. Have a very good day and see you in the next video.